Hello students, welcome. So here we are again with the new session, and here we are talking about solving inequalities. So there are a lot of inequalities which we come across in maths and in other subjects also, involving log, involving exponential, involving algebraic expressions, involving rational expressions. So there are some properties also. So how do we solve those inequalities? There are some graphical inequalities also. There is linear programming problem also. So there are many things. We can't cover all of these things here right now in this lecture, but we can understand some of the basic concepts and some of the important tips and tricks in order to solve some basic questions which are being asked at most of the places. Even if it is not exactly from this chapter, it may be used somewhere. So if you see that we have inequality, let us start from here, that x is greater than y or x is greater than equal to y. So one inequality here is the slack inequality, another one is the strict inequality. This is the strict inequality, this is a slack inequality. So slack means there is a possibility of equality also, but in strict it is a strictly inequality. So if you add a constant here x plus a and you add the same constant here y plus a, then also the inequality will not change, of course. Similarly, it will happen here also, the slack inequality will not change. If you will subtract a, where a is positive number, then also it won't change. What about multiplication? It won't change on multiplication also. So on multiplication what happens? It depends upon a with which we are multiplying. So if a is greater than 0, like if we take a is equal to 3, so can we say that 3x is greater than 3y? So we can say like this. But if a is less than 0, like we have a is equal to minus 2. So in that case, what will happen? Minus 2x will be less than minus 2y. So the inequality will reverse. So if a is less than 0, inequality reverse on multiplication, and if a is greater than 0, equality remains same. Now the next part here is division. So in division also, if you divide by a, you get the same situation, and if a is greater than 0, then it is same. If x is greater than y, x by a is greater than y by a, and if a is less than 0, x by a is less than y by a, like this. That is inequality reverse. So these are the four simple basic properties of inequality which we have to understand here. You can take an example also, like we have 3 which is greater than 2. Now you multiply minus 1. So minus 3 and minus 2, which is greater? Of course, minus 2 is greater. But if you multiply by 2, 6 and 4, which is greater? 6 is greater. So inequality doesn't reverse here, but the inequality get reversed here. What do we have next is that if there is a modulus function, in modulus also there is a concept of inequality, and that has to be understood. In modulus function, if we have mod of x greater than a, so what we say that in such situation, for example, mod of x is greater than 2. What does it mean about x? What can you say about x? It is the condition on mod x, not x, but what will be about x? So by modulus, we know that modulus represent the distance from origin. So what is mod x? It is the distance from origin. So suppose x is here, so this distance is mod x, or if the x is here also, then this distance is mod x. So whether x is negative or positive, mod x will be positive. So this is suppose 2 and this is suppose minus 2. So if you take x beyond 2 here, then we say that the distance is greater than 2, or you take beyond minus 2 on the left hand side, then also the distance is greater than 2. So in this region, distance is greater than 2, as well as in this region, distance is greater than 2. So what we see here, that either x should be greater than 2, this x should be greater than 2, or x should be smaller than minus 2. This x should be smaller than minus 2, not between minus 2 and 2. That region we won't take. So we say that x belonging to minus infinity to minus 2 union 2 to infinity. So, this is how we write it. Now, if you see here, mod x is greater than a, so you can say that either x is less than minus a or x is greater than a. This is what we have understood from this example. So, in this example, we have seen this. Now, if you see here that mod x is greater than a, that means that x belonging to minus infinity comma minus a union a comma infinity, and a is greater than 0. That you have to remember, mod x is greater than 2 obviously. If it is greater than minus 2, then all the real numbers, because from a negative value mod is always greater. So, for taking a negative, there is no point. I am taking a as positive only. There is no point in taking a as negative. Now, if mod x is less than a, then a, what would happen to x? X would be a and minus a. X will be between a and minus a. Now, why we would say that? That means that we have a here and minus a here, origin here. Now, we take x here, then this distance is mod x, and which is less than the distance a. If we take x here, then this distance is also mod x, and this is less than this distance mod of a, or we say a. Mod of a is same as a over here. So, the distance here is a actually. So, if we take here x between minus a to a, the region is basically from this point to this point, then we say then mod x is less than a. Similarly, if it is given that mod x is less than 3.7, so we can say that x lies between 3.7 and minus 3.7. So, it is between minus 3.7 and 3.7. This is how we can write the mod. So, these are some of the inequalities of mod. If there is a equality, suppose also here, which is also called slack inequality, then our definition will change here also, and it will change of course in these examples also. So, that is not a big issue. So, this is about inequality of modulus. Now, we come across algebraic expressions sometimes. Let us take some simple algebraic expression. Let us take x square minus 3x plus 2 is greater than 0. Now, what is the value of x which you can take, or what are the set of values of x which you can take? So, we will split the middle term. This will become x minus 2 into x minus 1, which is greater than 0. After doing the splitting the middle term, this will become x square minus 3x plus 2. Now, we mark 1 and 2 here. These 2 points are called the zeros. What do you call them, students? Zeros. And these are also called the critical points. Critical points are those points where this expression is becoming equal to 0. When x is equal to 2, then it is becoming 0. When x is equal to 1, then also it is becoming 0. Now, if you see over here that what are the regions? There are 3 regions, region number 1, region number 2 and region number 3. So, if you talk about these 3 regions, so the rightmost region we take positive here. Why we take positive? Just verify. Let us take a point 3 from here, for example, and put it here. So, 3 minus 2, it is a positive value 1, and 3 minus 1, it is a positive value 2. So, overall it is positive. Now, if we cross this critical point 2, we get negative. So, there will be an alternate change. This you have to understand, there will be an alternate change, because now if you take a value between 1 and 2, suppose 1.5, you will see that this value will be negative and this will be positive. So, the multiplication will be negative, and again we go here, it will become positive. So, the curve would be something like this. It is like this. So, you can say the function basically, which is x square minus 3x plus 2, this is the function. This is having at some region positive values, some region negative values. So, where does it having the positive value? That is being asked in this question. So, we will say that it is having positive value if you take from minus infinity to 1 union 2 to infinity. This is 1 or 2 is not included here. Why it is not included? Because there is not slack inequality, it is a strict inequality. If it would have been equality here, then you will include 1 and 2 also, where it will become equal to 0. So this is how you can do algebraic expressions. This is quadratic, you can do cubic also if it you can find the factors. Now if you have, suppose like this, x minus 3 to the power 4, x plus 2 to the power 7, x minus 5 to the power 2, x plus 7 to the power 2017 is negative. What is the region which we will take? So don't get frightened by the powers here, because powers will not have a very big role over here. The powers are making a role of even and odd. So basically powers you have to understand are even or odd, because that is the use here. So if you talk about the critical points, so critical points or zeros, first you have to understand them. So what are the critical points or zeros? So if this will become 0 when x is equal to 3, this will become 0 when x equal to minus 2, this will become 0 when x equal to 5, this will become 0 when x is equal to minus 7. So these are the critical points. Now can we plot them on the number line? So let us plot them on the number line. So we have minus 7 of course, then minus 2 here, then 3 here, then 5 here, minus 7, minus 2, 3 and 5. Now if we take the signs, then it is positive rightmost region. Why we are taking positive rightmost region? Because if you take any value from the rightmost region, this will become positive, this will be positive, this will be positive, this will be positive, because it is greater than all the critical points. It is greater than 3, it is greater than minus 2, it is greater than 5, it is greater than minus 7. So any point from this region is greater than all the zeros or critical points. So the subtraction will give you positive value. So you will get the multiplication as positive. Now if you will come between 5 to 3, what will happen? It will alternately change or not. So that will be decided by this 0, 5. So where is it? It is here, x minus 5 whole square. Now in the initial question, what we observed, that both the factors were having power 1, which is odd. 1 is odd power. So we were alternately changing the sign. But in this question, as you observe, the powers are even also, odd also, depending upon the powers. So basically when you talk about 5, this x minus 5 whose critical point is 5, it is having power 2 which is even. So this does not change the sign, this will remain positive. Why it will remain positive? Because a square will not change the sign. If even it is minus here, the square will make it plus. So if you take a critical point from here in this region between 3 to 5, then what will happen? Suppose you are taking 4. So this will become positive, this will be positive, this will be positive, and this will be negative square, that will be also positive. Now if you will come across 3, so what about 3? 3 is here, and what is its power? Its power is even. Again there will not change of sign, so this will be positive. When you will come to minus 2, so minus 2 is here, there is odd power, there is a change in sign. So there is a change in sign, it will become negative. Then we come to minus 7. Minus 7 is having odd power, 2017. Again change in sign, positive, from minus to plus. So what do you have understood here? That we won't change the sign, that there won't be any change of sign if the critical point is having the factor which is having the power as even power, and if the power is odd of that critical point factor, then we will change the sign. So what we have here is positive, positive, positive and negative, and then positive. So this is the curve. Now you have to find where it is less than 0. So it is less than 0 only between minus 7 to minus 2. You could have also solved for greater than 0. So for rest of the places it is greater than 0 or equal to 0. Suppose I make a question like this, making it more complicated. It is less than equal to 0. Equality is also there. So what will happen? If it is less than equal to 0, then in that x belongs to minus 7 to minus 2, where both of them are included. And after that we won't take this region, but we can take 3, because at 3 it is becoming equal to 0. So this is an isolated point. Then again we can take 5, which is isolated point. So these are the points which are either less than or equal to 0. So, do not miss these points here, because they are not in less than 0 region, because they are equal to 0 also. So, you can't miss those points. Now, I am talking about algebraic expression right now. Next, I am talking about rational expression. So, what happens in rational expression? I am taking a situation like this, that we have x minus 2 whole square into x plus 1 to the power 1011 into x plus 3 x minus 3 to the power 21 upon x plus 3 ka square into x minus 5 to the power 7 is less than 0. Now, this is the question. This is a rational expression, that is numerator by denominator. Numerator is a function, algebraic function, and denominator is also an algebraic function. Now, it is a rational function overall. So, what will happen? You will identify the critical points. How do you identify the critical points? Again, you will see that where the numerator is becoming 0. So, at 2 it is becoming 0, at minus 1 it is becoming 0, at 3 it is becoming 0. So, these are the zeros or the critical points. So, what you observe, that the critical points are zeros which are minus 1, 2 and 3. Now, there is one more thing, that is the denominator here. What about the denominator? Denominator is also getting 0. Where it is getting 0? At minus 3 and 5. So, can we say that they are also zeros? No, we can't say they are zeros. Of course, we can say that these are critical points, but these are poles. So, what do we call them? We call them poles. So, poles are minus 3 and 5. So, minus 3 and 5 are the poles where the denominator is becoming 0. So, what we will do here? We will put an open circle here at poles, because poles can never be included. Why poles can never be included? Because poles will give you the denominator 0, and if the denominator is 0, the rational function is not defined, because denominator is becoming 0. So, what is happening over here? That it is having 3 zeros and 2 poles. Now, how many regions it is having? 1, 2, 3, 4, 5, 6 regions. There are total 6 regions here. Now, if you talk about the rightmost region, so the rightmost region, which is after 5, is positive, as we were taking earlier also. Why it is positive? Because all x are greater than the critical points in those region. So, if we take curve like this goes here, but it won't cut the 5 point, because it is an open circle, it is a pole. Now, about 5, here it is 5 and its power is odd, so it will change sign, it will become negative. Then we come to 3. So, 3 is here and power is 21, it is odd. So, this will become positive. Then we come to 2, 2 is here, its power is even, so it will be positive. Now, we have minus 1, its power is odd, 1011, so it will change sign, negative. Then minus 3, its power is even, it won't change sign, it will bounce back, it is negative. So, once you can check easily that since there are odd powers here, here and here, so there should be change in sign there. 1011 is at minus 1, there is a change in sign. 3, there is a change in sign. 5, there is a change in sign. What about minus 3? Minus 3, there is no change in sign. 2, there is no change in sign. So, this is fine here. Now, what we have to see is it is less than 0. Now, it is easy to identify where it is less than 0. If you see here that x belonging to minus infinity to minus 3 union minus 3 to minus 1 and then union 3 to 5, like this. And if it is asked, for example, if I change this question little bit, because see, one thing you have to do, you have to make this curve, you have to make the sign scheme, you have to plot this, then only you can finally find the answer. So, the question part is later seen. First it is seen the what is the expression. Now, if the question is something like this, that it is greater than equal to 0, not less than 0, greater than equal to 0. So, our answer will also change. So, in that situation, If it is greater than equal to 0, our answer would be, let us see what our answer would be. X belonging to, here it is less, here it is less, here it is greater than equal to 0, here it is equal to 0, here it is greater than equal to 0. So we can directly say from -1 to 3, we should not break from -1 to 2 and then 2 to 3 unnecessarily, because 2 is also included, and then we have 5 to infinity. So 5 is not included. So 5 to infinity. 5 is not included because it is a pole. So this pole is not included in any case. So this would be our answer. Generally this is a mistake. Students include 5 also, thinking that it is greater than equal to 0, but equal to 0 won't include pole. It will definitely include zeros but not pole, because denominator will make the function undefined. Now if we talk about some changes here, for example, if it is minus x plus 2 to the power 13 into x minus 3 to the power 5 is less than equal to 0. So why, you will now say that why so many questions we have done and now this simple question. So this is not a simple question, there is a little variation here. What is the variation? Can you identify the variation? In earlier questions what was happening, that the coefficient of x was always positive. As we can see here, the coefficient of x was everywhere positive, 1. The coefficient of x here everywhere positive, 1. The coefficient of x in these factors was 1. But in this question, the coefficient of x, I am not taking 1 everywhere, here I am taking it as -1. And one more change you can take 2 here, so 2x minus 3. So I am taking -1 here and 2 here. Now let us find critical points or zeros here. So this will become 0 when x is equal to 2, and this will become 0 when x is equal to 3/2. So these are the two critical points. Okay, by equating this to 0, you will find x. By equating this to 0, you will find x. Now after finding the critical points, what you have to do, you have to mark the regions. What sign? We start from the rightmost region. So will the rightmost region positive here or negative? So the rightmost region will be negative here, not positive. Why it is negative? Because as you can see here, the coefficient of x here is negative. So if you overall see, the power here is 13. So when you take this minus sign outside, it will be minus x minus 2 to the power 13. This minus sign is taken outside into 2x minus 3 to the power 5, like this. So we can take like this. Now if we take like this, the question can be rewritten like this. It is less than equal to 0, and our function for which we are making the sign scheme is this one. Now this function is having a minus sign outside. If you make the coefficient of x positive here also, but outside it is minus. So the overall value on the rightmost region will be negative because there is a minus sign outside. Then at 2, you will see that its power is odd. It will become positive after changing the sign. Then again it is odd, 5. Then it will again change the sign, negative. So what will happen here? The sign scheme would be something like this. So this is how we can draw this curve. Now we can solve the question to get the answer. It is less than equal to 0. Where it is less than equal to 0? Minus infinity to 3/2. So it is minus infinity to 3/2 union 2 to infinity. So it is 2 to infinity. So this is how we can do this question. So there are a lot of many methods to solve inequalities, that logarithmic inequalities, exponential inequalities, and many more inequalities. But for this lecture, we will stick to this much concept, and we will discuss more in details in coming sessions and in our apps and in our lectures. Thank you, students.